Hello, class. We have a quiz coming up. Let me start that again. Hello, class. We have a test coming up. Unit 6 to be exact, exponentials and logarithmic functions. This is going to be the review. I might go a little bit quick, but you have the power to pause and stop, rewind, do what you need to do. If you have any questions, please contact me. I'm in my office most of the time during flex and lunch, and I have a lot of time. So email me or check in with me. Here we go. Starting off, let's go with some vocabulary. The basic example of a log form. We're just going to look at something that is log b of, say, y equals x. The basic example of exponential form, if you were to take that conversion, it would be b to the x power equals y. This is why they're related. You can convert from one to the other and back and forth. Common log is just called log. You don't have to put a base 10 there, but it's just common log with base 10. Natural log is ln. It is the log of e. But this is all I really want you to know. When you hear interest compounded annually, you're going to be thinking about p times 1 plus r to the power of t. If you have, that's annually. If you have continuously, then you're going to go with p to the e to the power r times t. PERT is continuous, whereas p1 plus rt is annual, just so one time. Looking at this log b of x equals y. What letter represents the base? That would be b. What letter represents the argument? The argument is going to be what is inside. So that's x. What represents the exponential? That was the y. Because if we were to rewrite this in exponential form, it would be b to the y equals x. So y up here is exponential to b. All right, let's just do some quick conversion. Note, we're not evaluating, we're not solving this per se, we're just changing the form. So right now we're going from exponential to logarithmic. That means we're gonna end with something with a log. What was our base on this one? Base 4. And it's gonna get you're gonna get a crisscross of these two numbers. So you're gonna get a 64 on this side and a 3 on this side. On the other side, we have e becomes natural log of y equals x. Now we're going to go the opposite way, going from logarithmic to exponential. In this case, we see what we have as a base is 2. These two kind of swap out positions. The negative 4 goes up as an exponential, and it's going to give you 16. This should make sense to you, because if you were to take 2, this negative exponent flips it, so you have, it's a fraction, and then to the 4th power, 2 to the 4th power is 16. In a fraction, but flipped as a fraction, it's 2 to the negative 4th power gives you 1/16. This one's slightly tricky, but it's for you to understand what does, in terms of logs or exponentials, how does the 10,000 relate to this 4? It's almost as if the 4 we know is going to be an exponential. So 4 to what power gives you 10,000? 10. Because 10 to the 4th power gives you 4 zeros, and that's your answer, 10,000. Let's see how well you use a calculator. Not gonna lie, this part is just you inputting numbers. Not as exciting in math, in my opinion, but it is a useful tool for you to know how to actually do exponential calculator work. you can plug, if your calculator is really fancy and lets you put in fractions as a exponential, you just have to make sure you put the parentheses. It would be the same as 5 to the caret of 3 divided by 4. That's going to give you 3 to 3, 4, 4. E to the negative 3 is going to be 0.049. This should be intuitive sense because you know that this negative exponent up here is going to bring it down to 1 over e to the third. And e is greater than 1, so it's going to get smaller and smaller. Natural log is just going to be 5.753. And log base 4, 62 is going to give you 2,977. It's very difficult for me to give extra partial credits on this. If you were to show some work, maybe I can do something with it, but it's a calculated input, so we're just seeing how well you input this. For log, remember it is log 64. Oh, for D, it's log 62 divided by log 4. I recommend you paying attention to where you put your parentheses. On a calculator, I see a lot of people make the mistake of putting log 62 log 4 divided by log 4. You have to close the parentheses first. Next question. Solve for x. 4 to the power of x plus 2 equals 64. Let's switch this over to log form, because unless we're just going to plug in x, we have no way of figuring this out. So right now it's in exponential form, so let's switch over to log form. Log base 4, switch these two spots, 26 equals x plus 2. We can do this calculation, which is log 26 over log 4. That becomes 2.3502, which brings this side down, x plus 2. Or this is, sorry, x plus 2, correct? And this is going to be minus 2 minus 2. So I have x is going to equal 0.3502. You can write that over here, 0.3502. Cool. Next up. Let's plug in some coordinates. We already have, the first one I would like to work with is 0, because I like to see where the intercepts are going to take place. 3 to the power of 0 is going to give you 1. Anything to the power of 0 equals 1. 3 to the negative 1 is going to be 1/3. Remember, negative exponent flips the denominator of the numerator. 1/3. 3 to the 1 equals 3. 3 to the 3 squared is going to give you 9. Everything here is the same, just reflectively bouncing over the denominator and the numerator. 27. So 3 to the negative 3 power is 1 over 27. Plotting out a few points. Not gonna lie, if I'm grading, I'm looking that you can tell me where the intercept is, and if you can give me some indication that it's gonna go up or down. In this case, it is going down, dk. Just as a quick note, we usually always say that if base is greater than 1, then it's gonna explode. But yes, this is greater than 1, but there's a negative here. So that flips it. So this is also the same as saying 1/3 to the power of x. Next up, you have y equals 5e to the x plus 2. I'm only asking for 4 points, so let's choose some easy points. First one that I always like to choose that's usually easy is 0. So 5 to the e to the 0 power plus 2. We're going to have 1 times 5 plus 2, so 5 plus 2 equals 7. Okay, we got 1. The rest of this, I strongly encourage you to utilize. When you have to actually plot out e, I recommend you using your calculator. So let's go with the -1, 1, and a 2. So with the -1, when you plot it all, when you plug in 5 times e to the -1 plus 2, you're gonna get 3.84. And if you have 5 times e to the 1 plus 2, you're gonna get 15.59. If you have plug in 2, you're gonna get 38.95. Again, what I care about the graph is, can you give me the coordinate, the intercept coordinate? So this is 0, 1. Over here, we're gonna go somewhere close to, let's just say that this is 0, 7. Is it going to go up or is it going to go down? This way it goes down, this way it's going positive, and it's going big. So along these lines, something like that. Growth. We're trying to get you to graph y equals natural log of x. First step, switch into exponential form. What is the base of natural log? It's going to be e. Swap the two sides, y equals x. Or, so the y power equals x. All of that being said, now we have the fun of finding some coordinates. In the directions, it does say select values for y to input into the equation. The reason why is because this is kind of counterintuitive. Normally we see something like y equals e to the x. But we're actually dealing with the log. So it is the inverse of y equals e to the x. And it's easier to plug in values for y than it is to try to plug in values for x and then work backwards. So with y, let's start off going backward, going with the y side. So we can do 0. I always like to start with 0. When I have e to the 0 equals what? 1. 1. -1, 1, and 2. -1 is going to give me to the e, 1 over e. It's going to give me e, and over here is e squared. Doing the actual math, I'm going to get 0.367, 2.718, and 7.389. Plotting this out, I want to make sure I know that when you're plotting this out, keep in mind which is the y and which one is the x. So we have the x-intercept is 1, 0. And these numbers are, as in between 1, it gets super close to So we're going to get a roughly that. Domain and range. Remember, all the possibilities of x, all the possibilities of y. Do I have any negative x's? No. So we're going to have the range for that is it's going to be positive. So 0 is less than x, but x is also less than infinity. Because it's going to go on forever on this side, but it does not cross this asymptote line. What is the range going to be? Well, we can see that it's going to be all of the negatives. It keeps going down in the y's. And as it goes all the way up, even though it's going to go shoot far to the right, it will still go all the way to the top. So that's all real numbers. Or you can say negatives infinity y and then infinity. All right, let's see how well we can understand our interests. So when you read this, you put $5,000 into account earning 5% interest compounded continuously. That's your key word. When you hear compounded continuously, your mind should immediately go to PERT. What is the amount in the account at the end of 7 years? Well, the numbers we got. P is going to be 5,000. R is 5%, or 0.05, and your T equals 7. So putting it into PERT, you have P E R T is going to be 5,000 times E to the R 0.05 times 7. Plug that into your calculator, you're going to get 7,095.34. If you're going to write this into a complete sentence, I believe that might be how I want you to practice just responding, because if someone asks you this as a question, your response would be something along the lines of, with a principal of $5,000 with 5% interest compounded continuously after 7 years, you would have $7,095.34. All right. Next one up is learning about population growth and declines. So as we read the statement, the population of frogs in a lake is decreasing. Decreasing is really important here, because knowing that it's going to decrease, our rate has to reflect that accordingly. So our first number that we're given is how many. There are currently 12,000 frogs. So that's going to be your A, your starting amount. Your rate, the population is decreasing by 8% each year. So your rate is going to be negative 8%, or negative 0.08. This one, we're not looking for what's going to happen after T amount of years. We actually want to figure out what happens when we only have, when will we ever reach 7,000 frogs left over? So this one is the actual amount that you want, which is the same as A to the T. So we want to figure out the end result to get to 7,000. And we're going to plug in the numbers that we know already, which is A, 12,000 times 1 minus, because we're doing with a negative percent 0.08 to what amount of time? Let's just work the easy math first. So 1 minus 0.08 is 99.2. Sorry, 0.992 to the power of t. Over here, we're still dealing with 12,000 is the initial amount, where we're starting at, current amount. And we want to look at it, what happens when how long will it take to get to 7,000? So let's isolate t, isolate our variable. Get rid of this 12,000 by dividing by 12,000. Do to one side, you must do to the other side. This cancels. You can cancel off 3 zeros on both sides. So we got 7 over 12 equals 0.992 to the power of t. Well, I don't know how to figure that directly. So how can I figure out that working with logs? So this is exponential form. Can we convert it into a logarithmic form? That's going to be log base 0.992 with the argument of 7/12 equals t. This one I can put into a calculator, and I encourage you to put in a calculator because I don't know these things off the top of my head. But if you're plugging into a calculator, you're going to get your t value is equal to 67.105 years. That's close enough, just 0.1. So if you write this into a sentence, after 67.1 years, the frog population would decrease to 7,000. 7,000. That's kind of depressing, but that's very possibly true. All right, the next part of the review, you're not supposed to be using a calculator. I will heavily warn you, do not use a calculator, because if you're using a calculator at this point, it will not help. The calculator, most of this part is very direct and easy because you're just converting things. If you're using a calculator, that means you're trying to put in numbers that are not going to come out very nice anyways. So if I were to ask you to write log of 4x over y squared in expanded form, that calculator won't really help you for this one. Because this is asking you, do you know your properties of logs? Properties of logs. In this one, so we have log. When you're inside the log and they're being multiplied, that means they're going to be adding. So log 4 plus log, I'm doing the first part on the top, log x. This division means there's a subtraction that takes place on the outside. Log y squared. Am I done yet? No, I'm not, because this part can still be expanded. So expanding that, I have log 4 plus log x minus, when you have it to the power, you can just bring it on the outside. 2 log y. That is your complete answer. Now if I were to simplify and bring it all together, check, are the bases the same? Yes, we have base 3, base 3. So let's add this, let's put those together. Log 3 is going to be the case of this one. Because we have a 5 on the outside, we have to swing him over onto the end to the exponential of what's inside. So x is going to be multiplied because we have an addition, so it turns into a multiplication. And then you have y to the 5th power. Can I convert to anything else? No, that is as simplified as it can be. So just as a quick review on this one, on the outside, if you see a minus, it's going to give you division. On the outside, if you see a plus, it's going to give you a multiply. If there's something to a power, or if something has a coefficient, on the inside, it's going to be a power. Kind of like this one right here. Evaluate log base 3, the argument 1 over 27. I'm just going to put a equals x. I can put any variable. It just helps me visualize this, because what I'm going to end up having to do is switch this into base form, or exponential form. So in exponential, my base is 3. I can put the x over on this side, equals 1 over 27. Given that it's a fraction on this side, I know that we're dealing with a negative. We're gonna be dealing with x is gonna have to be negative something. And how do I get 23? How do I convert x or 3 into 23? X or 3 times 3 times 3 gives me 27. And then if I had it as a negative, that gives me the 27, and I know that I was dealing with this negative. There are 3 times 3's, so x equals negative 3. You can check this by 3, negative 3 gives you 1 over 3 times 3 is 1 over 27. So my answer is x equal, or just negative 3. This one we're actually solving for x. So I like to switch it into exponential form. So 3 to the 4th equals x. That's just going to be 3 times 3 times 3 times 3. This gives me 9. 9 times 9 equals 81. I'm pretty sure that was exactly the question that we had on the quiz. There's only so many small numbers we can pick that you can do in your head without a calculator, so we try to use those ones. This one's a little more complicated, but I give you a hint. Common base. Right now, you have a base of 8 and a base of 2. They're not common yet. But how do I convert this 8 into something that matches the 2? Basically, how do I turn it into a 2? 2 to what power will give me 8? That magic number is going to be 2 to the 3 power gives you 8, because 2 times 2 times 2 equals 8. So we can substitute this into here. 2 cubed times to the power of x equals 2 to the power of 2x plus 1. When you have an exponential that is brought to a power of another number, that actually ends up just being multiplication. So that's 2 to 3x equals 2 to x plus 1. When the bases are the same, you can kind of ignore it. So that just becomes 3x equals 2x plus 1. Minus 2x minus 2x, x equals 1. That's nice and easy. If you want to check your work, you can always plug this number back in to your original equation, and you're going to get 8 to the 1 equals 2 to the 2, 1 plus 1. This is 2 plus 1 is 3. 8 to the 1 equals 2 to the 3rd power, which is correct. In log base, argument equals the exponent. Can the argument be negative? Can it? Can it? Because if it's going to be negative, what happens? Let's test it out. If I had b equals to a power of x, can I get a negative number? I don't know, -5. Because if this is going to be if b is positive and x is either positive or negative, it will make this number really, really big or really, really close to 0. But it will never bring out the negative side. So this could never happen. So this is false. This is really important because you're going to need it for the following questions, potentially. All right, log base 2 to the argument of 3x over x minus 1 equals 2. Your hint, change it to exponential form. So base 2, do the swappy swap. So base 2 to the power of 2 equals 3x over x minus 1. Well, 2 to the 2 powers is 4 equals 3x over x minus 1. I don't like fractions, so let's get rid of our fractions by multiplying by x minus 1, x minus 1. These cancels, this distributes, or x minus 4 equals 3x minus 3x minus 3x. Moving over here, that gives me x minus 4 equals 0 plus 4 plus 4 on both sides, x equals 4. X equals 4. We can plug it in. We should plug it in. So going into log 2, 3 to the 3 times 4 over 4 minus 1. That gives me log base 2, 12 over 3, which is also 4. So let's simplify that. 2 log base 2 to the 4th equals 2. Can I switch this into base form? Because that's just 2 to the 2 equals 4. Check. That makes sense. Also, the logs were never negative, so we're okay there. Next problem that we have is log base 3x plus log base 3 x minus 4 equals log base 3 of 5. So first thing that we're going to have to do is combine everything on one side into one log. So we have a plus here. What do we do when we plus? We get to multiply log base 3 x times x minus 4 equals log 3 equals 5. Cool. The log bases are the same, so we can kind of ignore it and just focus on the x minus 4 equals 5. Do some distribution. X squared minus 4x equals 5. Let's bring 5 on one side. This quadratic formula, how are we going to solve it? There are ways, but the easiest way is trying to just factor out. So we know that it has to multiply, give me -5, add gives 4. A few things that can multiply gives you 5. You're going to get a 5 and a 1. We want them to be negative, so one of these have to be negative, and we want the bigger number to do the addition to give you -4. So -5. -5 plus 1. So x equals -1 and 5. Is this our answer? Not quite, because we have to check. Given that the argument inside can never be negative, we have to check them. So log 3 with 5, that's okay. Log 3 of 5 minus 4, plugging this one in. we're going to get log 3, 1. That's still positive, so that checks. So 5 is okay. What about log 3 of negative 1? Can't have a negative 1. Bad. So negative 1 is out. So x can only be 5. I do want you to look and be able to read graphs and understand what the breakdowns are. So looking at this graph of compound, specifying compound interest, you're going to be asked to write about one of these. You don't have to do both, but I'm going to cover both of them just so that you have a familiarity of what to expect. If you're reading this, looking at how the graph is designed, can you tell me what the principal is? How much the initial investment is? Specified here that this is the principal, and it's staying constant at $1,000. It's in the title, it's compound interest of 10%, and for how long? 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. So over here is 20. You could also figure it out by reading the title. It's kind of very handy. So this part is the principal, the first 1,000. This part over here is interest not compounded. So if I were to, this is the hypothetical of if you put your money in a bank and that bank said, I will give you $5 each year. It's just a flat fixed amount. Doesn't matter how much it changes or how long, it's always going to be $5. Actually, in this case, it's closer to $100. $100 each year. And you're just getting $100 each year, $100 each year, $100 each year, $100 each year. That's cool. Over here, this compound interest it's saying, I'll give you 10% of everything that's in there. So that very first year when you had $1,000, 10% of that is exactly 10% of $1,000 is $100. But then the following year, now your bank doesn't just have $1,000. It has $1,100 because you have that additional $100. And now we're going to get interest on that. 10% of that is going to be $110. And so then you're going to add that into it. As this number gets bigger and bigger, it's that 10%, it just grows more and more. Just to test how familiar you understand things. If you had a choice between P times 1 plus R to the T, which is annual compounded interest, versus PERT, which is compounded continuously, which one will give you more money in the end? If all other numbers remain the same, PERT will generate more money over time. And back to my love of social media postings and things going viral. Here's a graph of a fictional posting that Mr. Dang posts. And Mr. Dang's normal posting rate yields this it's still an exponential curve. Don't diminish it too harshly, but it's a slow curve. It's not it's slowly building up. You can see it's working its way up. But there was one time when a friend of Mr. Dang reposted something that he did, and her popularity made the viewing of that one post skyrocket. So normally Mr. Dang's posting gets not that many hundreds of views after a few days or say weeks, but after that one post, within a few days, it reached thousands and thousands a few days after. In this case, this Miss Agron's base number, because Mr. Dang has probably a base somewhere closer to 1.5 0.05, I don't know. It's a small, kind of like those interest rates. It's a small number just above 1, and it grows slowly. But Miss Agron, this is Mr. Dang, but Miss Agron DA probably has something significantly higher. 550, I'm not sure. But with a big number, with a big base, it will go to the moon very quickly. If you were to be interested to note this quasi-triangle shape that takes place, this shape underneath the curve of Miss Agron's curve and Mr. Dang's original curve, is all the people that Mr. Dang does not know, but is friends with Miss Agron. This is the difference of her influence, her sphere of influence. Just a lot more people. Any questions? That's pretty much everything that we will be covering on the tests, and hopefully you'll do well. Please review this. If you want more material, review the lecture notes, because a lot of this is taken from the lectures. And good luck.